the next step here would be to write more functions. So mainly we will need three more functions. So the create or list NFT function that will take an NFT that you own and list it for sale. And we're gonna need buy NFT. This function will actually buy an NFT that is already listed for sale. And the cancel listing function that will um cancel a listed NFT, so it will remove it from being listed, right? So let's go ahead and start writing the list NFT function. Let's just copy past this. So it's gonna be list NFT, and it's gonna take a token ID, right? It's gonna be an unsigned int, public. And by the way, I don't really think this does anything, so let's just remove it. And this also won't return anything. It's gonna be just like this. And this function should also take a price, so unsigned int price. This is gonna be in way. Um, there are two things we need to handle here. We need a way to keep track of NFTs listed for sale somehow and their prices. And we also need to transfer ownership of the NFT to the market. So if you list your NFT for sale here, it's not gonna belong to you anymore. So while it's still listed, it will be belonging to the market. And if you want the ownership back, you can of course cancel it, and you'll get your token back. So, let's start by solving the first problem, and that's tracking listed NFTs. So to do that, I'm gonna use a mapping, a Solidity mapping. So to explain how that works, we basically so in JavaScript or TypeScript, you can have a object here. So mapping. So this is an object, and you can do mapping at token ID, for example, equals some object here. Let's say price, and let's say seller. So this is how it works in TypeScript. And you can like have multiple token IDs here, token ID 1, 2, and it's gonna have different data, right? Um, so this is exactly what we would do if we want to keep track of prices and sellers of NFTs if we were using JavaScript. So this is roughly what we want to achieve in Solidity. We need the mapping that where we can store NFT data. So let's try to do that in Solidity. Um, to store NFT data, we will need a struct. So let's declare a struct here. Let's call it NFT listing. It's gonna have an unsigned int price. It will also have an address seller. So this is the price of the NFT. This is the original owner of the NFT. And then we can do mapping. So this mapping will map token IDs, which are unsigned ints, to NFT listing objects, basically. And let's call um, this mapping, let's call it listings. And let's also make it private. So now that we have our mapping, let's continue writing our function. The first thing we need to do here is to assert that the price is greater than 0. So if you send a 0 price, we should not let it work. So let's do require price is greater than 0. And if it's not greater than 0, let's return this error message. So let's say price must be greater than 0. So if the price is not greater than zero, the function will revert. So the next thing we need to do is to allow this contract to transfer this token ownership. So basically, only the owner of the NFT can transfer the NFT ownership. So we want this market to be able to do that too, because if someone buys the NFT, we need to transfer the ownership of that NFT to the buyer. So the contract must be approved to do that. And we can do that by calling approve. Um, and it takes two and token ID. So we want to approve the contract. So we can do address dot this. This will return the contract address, and then we want to approve the this token ID that was passed in the parameter. Now, if the message dot sender, if the address that initiated this transaction is not the owner of this token, this will revert. So we are hitting two birds with one stone here. We are approving our contract to transfer this token ownership, and we're also asserting that the user that's the address that initiated the transaction is the owner of this NFT. So if these two lines execute correctly without reverting, we will be sure that everything is okay and we can proceed with listing this NFT for sale. Next step is to transfer the ownership of the NFT to the market contract. So we can do transfer from, and from is going to be the message.sender, to is going to be address this, and the token ID is passed in the parameter. Now that the ownership was transferred, we can store the listing data in our mapping. So let's do listing token ID equals NFT listing. The first parameter is the price. The second parameter is the seller, which is message.sender. And this should be listings. And this is pretty much everything we need to do in this function. Now let's start writing the buy NFT function. So function buy NFT, it's gonna take one parameter, the token ID to be bought, and it's gonna be public. It's not gonna return anything. So before doing anything in the function, we should check for two conditions. The first one is that the NFT with this token ID should be listed for sale. So you cannot buy an NFT that's not listed for sale. The second condition should be that the amount of ether sent to this function should be equal to the price of the NFT. So if you send something less or greater than the actual price, the function should revert. So first of all, let's grab the listing from our mapping and see if the NFT with this token ID is actually up for sale. To do that, let's do NFT listing, memory listing equals listings token ID. And to check if this listing exists, we can check that the price is not zero. So if it's zero, then there's no entry with this key in the mapping. So let's do require listing dot price greater than zero. If not, we're gonna revert with NFT market uh NFT not up, not listed for sale. So that's the first check. The second check is to make sure that the amount of ways sent to the function is equal to the price. So let's do require listing dot price equal, or let's do here message.value equals listing.price. So message.value holds how much way what was sent to the transaction. So that's how you access it, message.value. If not, let's throw this message NFT market price or incorrect price. And to be able to send way to this function, it should be marked as payable. So adding this will fix this error. So now we are sure that everything is good to go and we can transfer ownership of that token to the buyer. So let's do transfer from. So this NFT was listed for sale here. So the owner of the NFT is the market, NFT market contract. So let's do address um this. So let's transfer it from the market to the one who bought the NFT. So it's message.sender and the token ID is this one. So now that the ownership of the NFT was transferred to the buyer, we can send the money back to the seller. Um, so if you notice here, we don't have any fees for listing an NFT for sale. So everyone can list their NFTs for sale for free, but we will take a small fee when the NFT is bought. So when someone buys the NFT, we're gonna take 5%. So the market is gonna take 5% of the price and then send the rest to the seller. To send way to an address, we can use the transfer method. So we can do message.sender.transfer and I made a mistake here. Sorry guys. This should be listing.seller. So we should send the money to the seller and not send it back to the sender. Um, I'm actually just gonna leave this here and we're gonna discover this bug when we test this function in the next video. So just wanted to let you guys know. And we can do a listing dot price. So 95% is price times 95 divided by 100. This will complain because the address should be payable. So we can write this in a payable and this should stop complaining. Now, there's a better way to do this, and it's a best practice to always use the safe math library for mathematical operations. So we can import it from utils slash math slash safe math.sol, like I believe. Yep, and we can do using safe math for unsigned int 256. And here, instead of doing this, we can do dot multiply by 95 dot divided by 100. So this is the same thing as what we had earlier, but safer. So basically, there's no division by zero or anything here, but still, it's the best practice to always use the safe math library for stuff like this. So basically, when this transaction happened, when the buy NFT function executed, the amount of waste sent with the transaction was added to the balance of the NFT market. So when we do transfer, we are sending way from the balance of the contract, right? So let's say um, one ETH was sent to the buy NFT, then one ETH will be added to the balance of NFT market. And then we're gonna uh, send 95% of that one ETH to the message.sender. So we're gonna set it 0.95 and we're gonna keep 0.05 in the balance of the contract. So I hope that makes sense. So the final function of this contract is the cancel listing function. function cancel listing. It will take a token ID, and it will enable owners to cancel listings that they already made. So if you call list NFT and you change your mind, you don't want to sell it anymore, you can cancel it. So we need to check for two things. First, we need to check that the NFT with this token ID is listed for sale. If it does not exist in this mapping, the function should revert. Second, if it exists, we should make sure that the message.sender, the address that called this function, is the owner of that um, listing. So we basically compare the message.sender with the listing seller address. So first, let's grab the listing from the mapping, and it's going to be the same require statement. If the price is not greater than 0, which means the listing does not exist. So we should revert. The second requirement is that the listing dot seller equals message dot sender. If it does not equal message dot sender, then we should revert you're not the owner. So if these two conditions are met, then we're safe to cancel the listing. And to do that, we're gonna transfer, let's copy again this line, transfer from address this to message.sender, token ID, um, and that's it. One last thing I forgot to do is to actually clear the listing from the mapping, and let's do let's make a function for that. So private clear listing. It's gonna take a token ID, and to clear a listing, basically, oh, this is function private. To clear a listing, we can just do listings token ID dot price equals 0 and listings token ID dot seller equals address 0. So, and we can call this function from here, clearing the listing, and we also need to clear the listing when an NFT is bought. Um, you're gonna ask me, how are we gonna fetch the listings and display them in a front end in a web application? We don't have any function that uh, fetches all the listings. So like, shouldn't we have a function here, fetch listings that returns all the listings here, so we can use that and display them in a web application, just like what OpenSea does, for example? Well, that's a good point. We are going to fetch listings and display them in a front end application later, but we're not going to use a smart contract function for that because it's not convenient. Um, when we want to fetch listings like this, we want to have more capabilities than just fetching them. We will need, for example, pagination. So if we have like 10,000 listings, we don't want to fetch them all at once and display them. We want to fetch like 10 by 10 or something like that. So we want the results, the listings to be paginated. That's one thing. Another thing is we may need search. So we want to implement search so we can search for NFTs by name, description, or whatever. All of these things are kind of hard to implement in a smart contract, and it's not practical to do so. um, that's why we're gonna use the graph. And if you don't know what the graph is, it's a protocol that indexes the blockchain. So it uses events, the same event that we talked about in earlier videos, the transfer event, for example. So it listens for those events, and using them, it builds up a database of all the list. It can build a database of all the listings here, and we can query that database using a GraphQL API, and like we're basically gonna have a full-fledged backend with search, pagination, everything. Um, this is just an overview about the graph. We're gonna go in depth and actually implement our graph, our subgraph in later videos. And because we're gonna use the graph, we will need some custom events because the transfer event here uh, that's being emitted by the ERC721 is not enough for us. We need an event that has more parameters, the like the price, the token URI, and a bunch of other parameters. So what we're gonna do is we're gonna create a custom event and emit that event in all of our functions. So let's do event it's called NFT transfer. So it's gonna take a bunch of parameters. Let's see. The first is gonna be an unsigned int token ID. The second parameter is gonna be the address to which this token was transferred. So address to. The third is gonna be token URI, it's a string. The last parameter is gonna be the price, so unsigned int price. So let's emit this from the create NFT function. So emit NFT transfer. The token ID is current ID. The two is message.sender. The token URI is the one passed in the parameters, and the price will be 0. Now, if the price is 0, will know that um, either it was created or it was bought or cancelled. So the only case where the price is greater than 0 will be when an NFT is listed. And the only case where the token URI will be uh, a string is when the created NFT was called. So in all these other functions, the token URI will be an empty string. If it doesn't make sense, just follow along. It will make sense later. So let's emit the same event in the list NFT, but the ID is gonna be token ID. The two is gonna be address of the contract. So because it was transferred to the contract here, so address this. The token URI is gonna be an empty string as we just said, and the price is price sent in the parameter. Let's emit the same event here too. So when an NFT is bought, the token ID is token ID. The address is gonna be the message.sender. The token URI is gonna be an empty string, and the price is gonna be 0. Um, in the cancel lesson, um, the token ID is the token ID. The message.sender is the 2. The token URI is an empty string and the price is 0, the same as this one. So basically, let's comment this. Let's do some documentation. If token URI is not an empty string, then create NFT was called. Or let's do an NFT was created, right? If price is not 0, an NFT was listed. If price is 0 and token URI is an empty string, NFT was transferred, either bought or the listen was cancelled. Hopefully this makes sense. It's not gonna if it doesn't make sense now, it's okay. it will definitely make sense when we start using these events, using the graph protocol. Um, Actually, I forgot a very important thing. Remember those 5% fees that were taken every time an NFT is bought? As I said, that ether, that money is stored in the contract balance, and currently there's no way we can make use of that money. So there's no way to transfer it to a wallet and spend it somewhere. It's forever stuck in the contract balance. And it's very sad. Imagine if we deploy this contract and people start using it and we make a lot of money, and then we discover, hey, we can't actually use that money. It's stuck in the contract balance forever. We can't send it to our wallet. So that's a total disaster. And let's make sure that that won't happen here. So we will need a function we can call to withdraw all of the money in the contract balance and send it to a wallet address. So let's create a new function, call it withdraw funds. It's gonna be public. And even though it's public, we only want one address to be able to call it. So not anyone can call this function and withdraw funds to their wallet. So we should take care of that. Usually the address we want to withdraw funds to is the owner of the contract. We can do this in a bunch of ways. The most straightforward way is to just hard code an address in the contract. So address private owner and just copy paste your MetaMask address like this. And in the withdraw funds function, we should require that the message.sender equals the owner. So only the owner can call this function. If not, we should revert with the message here, not the contract owner. So this is one way. Another way is to assume that the address that deployed the contract is the owner. If so, if the owner is the one who deployed the contract, we can just do owner equals message.sender in the constructor, so we can get rid of this address here. So the owner will be the one who deployed the contract, and we can still do the same logic here. So this is the second way, and this pattern that we just implemented is very common. That there is a contract that does all this job for us. So we can go to the open Zeppelin docs. Um, Contracts and go to access control, and there's this ownable contract that does exactly the same thing we did here. So um, it gives us the only owner modifier that we can add to any function, and then only the owner can call that function, as you can see here. You can do your own read-in, but let's just go ahead and check the code. Um, so go Let's go to the GitHub. So as you can see in the constructor, it's calling underscore transfer ownership message sender. So if we go here, this is the transfer ownership. Basically, it sets the owner to the new owner and it emits an event with the old owner and new owner. So basically, it does the same thing that we did here. It sets the message sender as the owner in the constructor. And also it provides the only owner modifier that like adds this line to any function that we add the modifier to. So owner equals message.sender. This is basically the same thing that we did here. So this logic is already exists. So we can just make use of it instead of implementing it from scratch. So let's delete these lines um, and import the ownable contract. Um, and we can do ownable here. Let's also not forget to delete this variable, and we can mark this as only owner. This should work. So now that we made sure that only the owner can call this function, we can go ahead and transfer the funds to that owner. So to get the contract balance, we can do address this dot balance. So this is the balance of the contract. So let's store it in a variable um, balance, and we actually should require that balance is greater than 0. If not, let's revert with NFT market balance is 0. So if the balance is greater than 0, we can transfer it to the owner, and the ownable contract gives us the owner function that just returns the owner variable, so we can use that, and we can do owner dot transfer balance, just like that. And what's the error here? Can we do payable owner dot transfer? Yep. So this will transfer all the balance to the owner of the contract, and this way the funds will not be stuck forever in the contract balance. So this is probably the last function in this contract. In the next video, I will be testing everything. So see you guys then.